Okay, we're back here, another edition of Algebra 1. Section 2-3 moving on now, and the next step is to solve multi-step equations. So we did solving equations, one-step equation with only one step that we had to work with, and now we're moving on where we're going with 2 steps. It'll be 2 or more multi-step equations. Okay. So what is a multi-step equation? It's an equation to solve with more than one step to isolate the variable. So before we were just either adding, subtracting, multiplying, or dividing, just doing the inverse operations one time. Now there'll be multiple steps to it. So an example here would be, for example, if we use 2x minus 7 equals 13, we'd have to do 2 steps here. So we'd add 7. Some of you guys have seen this before. We'd add 7 first to both sides, and then we would divide by 2. So 2 steps to that one. And when we solve these, we're still using inverse operations. So we're still doing the opposite. But one thing to keep in mind is we're going to follow the order of operations backwards. So you're kind of going to undo them a little bit differently. And what I mean by that is we're usually undo by adding and subtracting first, and then multiplying and dividing after that. Of course, there's always a few exceptions to the rule where in math sometimes we do something a little different. There's some exceptions to that. That's a general rule, and we'll do some problems where we have those exceptions to the rule. And then we want to work until we get the variable isolated, or you solve for the variable, or in other words, the coefficient is 1. Coefficient is 1. Okay, so let's do a couple practice problems here. I feel pretty good about number 1, thinking you'd be able to do the opposite, add 17, and then divide by 7. So let's take a look at number 2. It's got a fraction in it. Sometimes those are a little interesting. Okay, so we're looking at inverse operations. So the first thing we want to do is, if we look at where the variable is, we're looking at right here is the variable. So what's happening to it is being divided by 8 and then added to 21. So we want to do inverse operations, but we want to use order operations backwards. So we're going to go ahead and subtract this 21 first, and then rewrite the problem that way. So now we can bring this down to have t over 8. These are going to cancel out, obviously. And it's going to be t over 8 equals -7 here. 14 minus 21 would be -7. Okay, so now we're 1 step to go. Now we are dividing by 8, so we have to do the opposite of dividing by 8, which is multiply by 8. So inverse operations tells us to multiply by 8 here, but we've got to do it to the other side as well. So when we do that, of course, we talked about these 8s are going to cancel out. And then over here, you're going to be left with a t equals a -56 when you compute that. Okay? And I just want to talk a little bit about checking your solution, what that means. It's kind of like those problems a few lessons ago we did the replacement set, and you just kind of checked for numbers and see if it was a true or false statement. We're just going to take this 56 and plug it back in here and see if it works. Just do the mental math or plug it in your calculator to see if that is actually a true statement. So that's what it means when it says check your solution. Okay, let's go down to number 4. It's a little interesting problem. So number 4, we've got 2/3 x plus 5 equals a -7. So again, we're going to do the same action here, and we're going to do inverse operations, order of operations backwards here. So we're going to subtract 5 from both sides. And then notice when I rewrite the problem here, I've got 2/3 x, and I'm going vertical, up and down. Some of you guys want to do your work horizontally. That gets confusing, and so I don't really want us to do that. I want us to go up and down from now on. Vertical alignment will help you. So 2/3 x, then that would equal a -12 here. -7 plus a -5 is a -12. Okay, so now we're doing the inverse operation here, and you could divide by 2/3 on each side, or you could multiply by the reciprocal, which is 3 over 2. So inverse operation, 3 over 2. And we're going to do that over here as well, 3 over 2. So again, all these would cancel. All these would cancel, and you'd be left with x here. And if you don't like the canceling idea, just think about what would happen here if you did multiply across. 3 times 2 would be 6. 2 times 3 would be 6 over 6x, and then that would be reduce to 1 anyways, so it would be 1x, which would give you that x over there. So you can do that way, or you could cancel it out just like you did there. Okay? So we have x on the left side, and the right side now, we can do this any way you want. If you want to compute it in your calculator, if you have mental math, you want to do some cancelization, whatever you want to do, any tricks you have to get this problem over here, but you should end up with a negative 18. And then you can do that solution check as well by plugging it in for x. Okay? I do want to look at number 3 because it's a touch different from number 4. You know, number 4 has a fraction, and so does number 3. But number 3 is a little different because you have p minus 15 over 3. And in this case, in the last problems, we just went ahead and added, in this case, it would be the 15. But you can't do that because p minus 15 is the total numerator. So there's a bunch of junk going on here that we can't necessarily deal with yet because of that new denominator of 3. So what we want to do is we want to get rid of that fraction first. So this is one of those examples where it helps to, where it's an exception to the rule. We can't do the inverse operations backwards here. Let's get rid of that fraction first. And a lot of times I tell you this helps. If you don't like fractions, get rid of them. So multiply by the denominator. So if we multiply this side by 3, of course, we have to do it on the other side because of principles of equality. So that's going to cancel this one out here. And you're going to have p minus 15 equals a negative 18. Now we can simply add 15 to each side. And now we should have a final answer of p equals a negative 3. So there you go. And notice the difference between number 3 and number 4. Very similar problems, but there is a major difference in the order in which we attacked it. Okay? All right, moving on. Write an equation for the problem, then solve the equation. I'm going to skip over these just because we did these in section 2.1, writing the equation down and then solving, but writing the equation down. Now all you're doing is solving them. So I have faith that you guys can do those on your own. All right, let's talk a little bit about consecutive integers, what that is. Okay, what is a consecutive integer? So we talked about these integers in counting order. Integers in counting order. So let's say we just started with 1 and said it was, let's start with the number 2. So consecutive integers would be, say, 2, 3, 4, 5, 6, and so on, forever, right? Okay, if you want to see the pattern, what happens? I mean, it seems foolish to think about this, but what's the pattern from one to the next? Right? Yeah, you're adding 1, right? When you go to the next one, you're adding 1. The next one, you're adding 1. It's always going to be adding 1 more, okay, with your consecutive integers. Now, when they talk about consecutive even integers, let's again start with 2 and just look at, okay, well, 2, then 4, then 6, then 8, and so on from there. Now, what happens? What's the pattern like here? What's the pattern like? So now, each time we go up, we're going to add 2. We're going to add 2. We're going to add 2. Okay? So that is the pattern that we're looking at. And I want to look at the odd integers too. We understand our first few odd integers are 1, 3, 5, 7, 9, and so on. But again, what's the pattern? A lot of people think, mess up this part because they say, well, it's odd, so it has to be some kind of odd number. No, you're still going up by 2 each time. 1 plus 2 equals 3. Plus 2 to get from 3 to 5. Plus 2 here. Plus 2 here. So you're always adding 2 here. So just keep those in mind as we look at the next problems. Okay? Write an equation for each problem, then solve the equation and answer the problem. So we can do these. Let's just look at one of them. Let's look at the first one here and see what we can do. So we've got to find 3 consecutive integers whose sum is 57. All right, so the first thing we're going to do is look at this sum of is being 57. Okay, so again, we're starting with this is our equal sign, and then that 57 can go, on the right here. So now we're looking at the left side of this problem saying find 3 consecutive integers whose sum is 57. So when we do this, if we see we didn't know what the number was, we're going to have 3 consecutive integers, and we don't know, what that number is. So if we don't know what the number is, we can easily say it's x, right? And let's just pretend that it was, say a 7. And it's not, but just for example, let's say it's a 7, right? So if it was 7, the next one would be 8, and the next one would be 9, right? So if we go ahead and use x instead, well, our pattern would tell us this would be x plus 1, and then the next one would actually be x plus 2. And if there was a fourth number, it would be x plus 3, x plus 4, and so on. Okay, so now we've got our equation, and now let's go ahead and combine like terms. Okay, so we do have an x here, here, and here, so that gives us a total of 3 x's. So we have 3x, and now we do have also combined like terms with our numbers as well. So we've got 1 plus 2, which is 3. So just after combining like terms, now we're in a situation where we've got a two-step equation. So we're going to go ahead and inverse operations, order of operations backwards. So we would get a 3x. These are going to cancel out, and 3x is going to equal 54. And when we divide by 3 here, you would get a final answer of x equals 17. Or, excuse me, my bad. X equals 18. X equals 18. Okay, so then we want to find the next two numbers. Remember, because it says they want 3 integers, 3 consecutive integers. So the next answers would be 19 and 20, because it's 3 consecutive integers there. Okay, so check out letter B. Now you're talking about even integers. That's the little trick there, 3 consecutive even integers. So notice the pattern is going to be different on that one. Okay. And then here's a word problem. Take a look at it. A lot of you guys can decipher it through here and just kind of work it piece by piece to figure it out. And we'll try our best to see what we can do there. Okay? And we'll answer any questions you have on that one. But I want you to give that one a try as well. Okay, so that takes us to the lesson summary. How would you explain consecutive integers in your own words? Let's say somebody came up to you on the street. It happens all the time. People come up to you on the street and says, hey, what's a consecutive integer? And then you've got to find a way to explain it in your own words. What would you say? So that's the lesson summary. And your practice problem, solve for x here, multi-step equation, x plus 3 divided by 5 equals -2. So go ahead and solve for that. Okay, so that does it for section 2-3, multi-step equations. Hope you enjoyed the show, and we'll see you tomorrow for some more action on this, and we can answer any questions you've got. I can go to work. All right? See you later.